Good morning, students. Students, today we will do scattering of light. In ninth class, you have done Tyndall effect. You know very well that scattering of light by colloidal particles is known as Tyndall effect. Scattering of light, it is defined as phenomenon of change in the direction of light as it strikes any obstacle, and the obstacle is known as scatterer. Scatterer can be a molecule or an atom of any gas, a water droplet or a dust particle, etc. Now look here, an incident ray, light ray falling on scatterer. Scatterer can be any atom, molecule of gas. There are so many gases present in air. It can be atoms or molecules of gases. Then after striking the scatterer, light it scattered in different directions. In different direction the light scattered. This is known as scattering of light, and it is done by scatterer. Factors on which intensity of scattered light depends. There are two factors. First one is mass of scatterer. Very fine particles scatter blue colored light maximum of short wavelength. Big particles scatter red colored light of longest wavelength, and very big particles they scatter all color or all wavelength in equal amount, and the object appears to be white. Second factor is intensity of scattered light. According to Lord Rayleigh law, intensity of scattered light is inversely proportional to fourth power of wavelength of the light. So red light has longest wavelength, so it is least scattered. Violet light has shortest wavelength, so it is maximum scattered. Yes, students, now we will do phenomena related to scattering of light. First one is why sky is blue in color. The reason is when sunlight enters into earth atmosphere has very fine particles of gases. So when sunlight strike these very fine particles of gases, it scatters blue colored light maximum or short wavelength, and the sky appears to be blue. Now the question arises, violet and indigo color, they have much shortest wavelength, but why the sky does not appear to violet or indigo to us? The answer is the spectrum of light emission from the sun is not constant at all wavelengths and is observed by the high atmosphere. So there is less violet in the light. Moreover, our eyes are less sensitive to these colors. We are more sensitive towards blue color and we see sky blue. Now why sky appears dark to an astronaut? The reason is astronauts they travel in space or vacuum, and where there is no atmosphere. In vacuum and in space, no scattering of light will take place, and the sky it appears dark to the astronauts which are flying very high. Now next is why clouds are white in colors. See, the clouds are white in color and sky is blue in color. The reason is the clouds are located in the lower layers of atmosphere, very near to the earth. The lower part of earth atmosphere scatters light due to the presence of dust particles, water droplets, etc. present in air. In such situation, the size of the scattering particle is bigger than the wavelength of light. As a result, what will happen? All colors or all wavelengths are scattered almost equally. So they all merge to produce white light, and the clouds, they appear to be white to. Yes, why danger signals are red in color? Now look at this. Warning sign displayed on containers containing concentrated acids and bases. They are also given red sign, red color, because red color is having longest wavelength and it is least scattered. It can be seen from distance during fog or mist also. That is why danger signals, they are given red colors. Next is why fog light is yellow in color. Now you all know that danger signals are red color given universally. In the whole universe, red color is given to danger signals. So after red color, orange is having longest wavelength, but orange, it resembles red. So after orange, yellow color is having longest wavelength and it is least scattered. So yellow color can be seen from long distances during fog and mist. That is why fog light is given yellow color. This is fog light and this is headlights of the car, which gives white light. Fog lights are given yellow color. Next is why sun appears white at noon and reddish during sunrise and sunset. Now look at this diagram. At noon, sun is overhead. The distance between the observer and sun is shorter distance. So little of blue light is scattered on the way and sun appears to be white in color. But during sunrise and sunset, the sun is near the horizon. The sun is far away from the observer. Most of the blue colored light is scattered away and mainly red light reaches us, which is least scattered, and the sun appears to be reddish in color during sunrise and sunset.